This is 2023 Ordinary Level Maths Leaving Cert Paper 2, Question 1, Part A. So we have the points A and B are 2 points on a coordinate plane. Work out the slope of A and B. Okay, so formula for slope is y2 minus y1 over x2 minus x1. So all you got to do is identify these points here. So we have 4, 2. And 1, 8. So let's call this x1, y1, x2, y2. Put those numbers into the formula. So we've got y2, which is 8, minus y1, which is 2, over 1 minus 4. That gives 6 over minus 3, which is minus 2. So that's it for part A1. Part 2 then, work out the distance from A to B. So same thing again, you've got your x1, y1, x2, y2. Write down the formula. It's in your tables. It's just the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. So let's see, our x2 is 1 and our x1 is 4. So it's going to be the square root of, again, 1 minus 4 to be squared, plus, and then our y2 is 8, so it's going to be 8 minus 2 to be squared. So when we do that, we get 1 minus 4, which is minus 3. Minus 3 squared is plus 9. Plus 8 minus 2, 6. 6 squared, 36. So that's the square root of 45. And if you stick that into your calculator, it'll give you 3 root 5. There's our distance. Find the equation of a line through the point minus 2, 7 with slope of 1/3. Give your answer in the form. Okay, so the equation of a straight line is y minus y1 is m into x minus x1. Again, it's another formula in your tables. So you got y minus y1, which is 7, is equal to our slope, which is 1/3, x minus minus 2, which is plus 2. Next thing you would do is take the 3 and multiply both sides by 3. So we're going to do 3 times y minus 7. The 3 on this side will just cancel with this, and we're just left with x plus 2. Multiply it out then, you get 3y minus 21 is equal to x plus 2. Now, that's the equation of our line, but we need it in the form ax plus by plus c equal to 0. So put the x here, then bring over the y, so it's going to be minus 3y. Bring over the 21, so that becomes plus 21, plus 2, which is plus 23. And that's it. That's the equation of your line. Okay, so let's move on then. The point 4, 2 is shown in each of the coordinate diagrams below. Draw a line segment through the point 4, 2 with a slope of 2 on the coordinate diagram below in the range y between minus 2 and 6. So we need a slope of 2. So a slope of 2 means you have a line and you draw a triangle from the line. A slope of 2 would mean you have 2 here and 1 here. The 2 is the rise, the 1 is the run. So basically we need to go out 1 and up 2 to this point here. So that's going to be a point there. We need to go down 2 and across 1. So that'll give us another point here. And we can go down 2 and across 1. Here we can go across 1 up 2 to here. So you just draw a line through that, use a ruler. Now I don't have a ruler, so I've got to do this freehand, but you should end up with a line that looks something like this. Should be a straight line anyway. And you can see here, if you go over 1, you go up 2 squares, so that's 2 over 1, giving us a slope of plus 2 over 1. If it slopes this way, it's positive. If it slopes this way here, it's negative. Okay, so that's all we had to do there in the range y from minus 2 to 6. Second one then, draw a line segment through the point 4, 2 with a slope of minus 2 over 3. Okay, so minus means it's going to slope this way, which means when we do our rise and run, this is going to be 2, this is going to be 3 here. So if we take our point here, we've got to go over 3, 1, 2, 3, and then we've got to go up 2, 1, 2. So we're going to put a point here. Let's do that, put a point here. Let's do the same from the other side then. We've got to go over 3, 1, 2, 3, and go down to 1, 2. So we're going to put another point here. So we have to go from x is minus 1 to 7. So we've got to go all the way over here to minus 1. So let's just do that anyway. Let's draw our line. There's going to be a line down through here. Again, this is a bit wobbly. I'm doing this freehand. You have to use a ruler. Continue that up along here, and it finishes around there somewhere. So again, use a ruler, make sure it's a straight line. So we've drawn the slope minus 2 over 3 between x is minus 1 and 7, between minus 1 and 7. So that's it really. Okay, next question, question 2. S is a circle, x squared plus y squared is equal to 25. Write down the center and the radius of the circle. So the center is going to be 0, 0 because we have an equation of a circle in the form x squared plus y squared is equal to r squared. That's the equation of a circle with center 0, 0 and radius r. Now the radius is going to be the square root of 25. This is our r squared, so we've got to square root that in order to find what r is. So it's going to be the square root of 25, which is 5. So our radius here is 5. Okay, so next one then. Show that the point 3 minus 4 is on the circle. So all we got to do is write down our equation. X squared plus y squared is equal to 25. So we have x squared plus y squared is equal to 25. Show that the point 3 minus 4 is on that circle. We'll stick a 3 in there, stick the minus 4 in there, and we should get 25. So here we get 3 squared, which is 9, minus 4 squared is 16, plus 16, 25. 9 plus 16 is 25. It is equal to 25. That's it. That's done. Okay, next one. Write down the coordinates of 2 other points that are also on the circle. So a couple of ways of doing this. I mean, you could write down the equation anyway, which is x squared plus y squared is equal to 25. So let's have a look at that. X squared plus y squared is equal to 25. Well, if it has its center 0, 0 and radius 5, you know, you're going to have a circle, you're going to have a radius, a radius of 5. So that means this is going to be 5, 0, this is going to be 0, 5, this here is going to be minus 5, 0, and this here is going to be 0, minus 5. So that's 4 points actually, but I mean you can do it algebraically as well. You could just say let x equal to 0. So if you let x equal to 0 here, you get 0 squared, which is just 0, plus y squared is equal to 25. That gives you y squared is equal to 25. That gives you y is equal to plus or minus 5. So that means when x is 0, y is 5. When x is 0, y is minus 5. Now if you did the same with the y, if you let y equal to 0, you'll get the same thing. You'll end up with these 2 points here, where the y is 0, minus 5, 0 and 5, 0. But this is sufficient anyway. It just says write down the coordinates of 2 other points, so I've done that. Find the point of intersection of the circle and the line. Okay, so the way you do these ones is you start with the linear one, the line. You get x in terms of y or y in terms of x. And you substitute it into the other equation. So we're going to look at getting y in terms of x. So bring the 5x over, it becomes minus 5x. Bring the minus 13 over, it becomes plus 13. Multiply everything by minus 1. And you get that. So all I've done there is just multiply by minus 1. Now the next thing we're going to do is substitute that into the circle. So we have x squared plus y squared. Well, we already have y here. We know that y is 5x minus 13, which we've got a square. This is just our y squared. And then that's equal to 13. So we've got to work through this to find 2 values for x. So let's do that. So we have x squared plus, we've got to square all this out. Well, that's just 5x minus 13 times 5x minus 13. So you got to multiply that by that, that by that, that by that, and that by that. So let me just do that out in my head here. So you get 5 5's 25x squared, and then you got 5x times 13, which is minus 65x. You've got minus 13 times 5x, so again that's another minus 65x. And then you've got minus 13 times minus 13, that's plus 169, that's equal to 13. Okay, here we've got x squared plus 25x squared, that's 26x squared. Minus 65 minus 65, that's minus 130x. Now you've got plus 169 minus 13, that's plus 156, and that's equal to 0. So all I've done is I brought that over here. So 169 minus 13 gives you 156. Now with this we can start dividing it by various things. You can divide by 2 and so on, but what you'll see, or what you should see here anyway, is that you can actually divide all this by 13. So if I divide 26 by 13, I'll get 2. If I divide this by 13, I'll get 10. And if I divide 156 by 13, I'll get 12. So what you should spot here is that you can actually divide again by 2. So that gives x squared minus 5x plus 6 equal to 0. So here we divide it by 13, here we divide it by 2. So let's see, we can factorize this anyway. So that's x times x. 6 can be 3 times 2. We need a plus 6, so it has to be minus minus or plus plus. Because we have a minus 5, it's going to be minus times minus. So that gives x minus 3 equal to 0, or x minus 2 equal to 0. And if you do that, you get x is equal to 3, or x is equal to 2, if you bring the 3 and the 2 over to the other side. So we found our two x values. What I need to do now is find the two y values. So if x is equal to 3, just put that into one of the original equations. I'm going to put it into the linear one, it's usually easier. So 5x minus y minus 13. So you got 5x minus y minus 13 equal to 0. Put in the x here, so it's going to be 5 times 3 minus y minus 13 equal to 0. 3 5's 15 minus y minus 13 equal to 0. That gives, let's see, minus y plus 15 minus 13 is plus 2 equal to 0. That will give me minus y is equal to minus 2 if you bring the 2 over, or plus y is equal to plus 2. So my first answer here is x is 3, y is 2. That's my first answer. So let's take x is equal to 2 now. This is kind of a long-winded question, but you just follow through the algebra. So it's 5x minus y minus 13 equal to 0. Put the 2 in. 2 5's 10 minus y minus 13 equal to 0. So now we've got minus y, now we've got a plus 10 minus 13, that's minus 3 equal to 0. That gives minus y is equal to, bring the 3 over, it becomes plus 3. That gives me a y is equal to minus 3. So my second answer is x equal to 2, y is equal to minus 3. So that's it for that question. Okay, so let's have a look at the next question. So question 3A1. In how many ways can the letters of the word camogie be arranged? So let's take the word camogie. C-A-M-O-G-I-E has 7 letters. 1, 2, 3, 4, 5, 6, 7. So that would just simply be 7 factorial. 7 factorial is 5040. So 5040 different ways. Okay, let's have a look at part 2 now. How many of the arrangements in part A1 start with M and end with a vowel A, O, I, or E? Okay, so I've drawn out 1, 2, 3, 4, 5, 6, 7 boxes, and we're just going to start with the restrictions here. The restrictions, the first restriction is that they must start with M. So if they start with M, then you've only got one possibility for the first letter. If it must end with a vowel, then you must come down here to the end, and there are 4 possibilities out here. After that, you go back to the start again, to the second one here. Now, if we've chosen a letter for the first letter, chosen a letter for the last letter, there are only 5 left. So we've only a choice of 5 here. Once we've chosen those 3, we've only 4 left, 3 left, 2 left, and 1 left. When you do that, you get 480. So there are 480 arrangements which start with M and end with a vowel. Okay, next one then. How many arrangements of 3 different letters can be made from the letters in the word camogie? Now it says how many arrangements can be made. So that's going to be N, P, or. So our N is 7. So how many ways are there of arranging 7 letters 3 at a time? So or is 3. If you do that, you get 210, and that's it. Next one then, 3 scatter plots are shown below. They are labeled A, B, and C. Each scatter plot has the same axis and scales. The correlation coefficient for each scatter plot was calculated. The results were 0.95, 0.6, and minus 0.95. Write each of the letters A, B, C in the correct place in the table below to show which scatterplot corresponds to each correlation coefficient. Use each letter only once. Okay, so we have 2 positive ones here and 1 negative. This is a negatively sloping graph, and these are 2 positively sloping graphs. So the negative one is going to be A. So this is going to be A here. Now you've got 2 positively sloping graphs here. The correlation coefficient here is higher than the correlation coefficient here because these are closer together to, you can imagine a straight line going up through these. These points would be closer to that kind of average straight line, or line of best fit if you like. If you drew a line up through these to show the general trend, the points are not as close as over here. So therefore this would have a higher correlation coefficient than this one here. So B must be the 0.95 and then C must be the 0.6. Now it says here, for scatterplot B, explain why the value you picked is correct. Okay, so we can say that B and C have positive slopes and A has a negative slope. There is a stronger positive correlation in B compared to C, since the points are closer to a line of best fit compared with C. Okay, again, you know, this is just my own explanation. You guys may have written something different down, and I may have gone into it in too much detail there, but that's generally the reason. I mean, these, if you imagine a line going up through these and a line going up through these to show the trend, these points would be closer to the line than this one here. This is positive, this is positive, this is negative, so it couldn't have been A, it had to have been B or C. So this graph here would have a higher positive correlation coefficient than C. Okay, so let's move on to the next question. So this is question 4. Rowan plays basketball. So part A, during the match, Rowan takes a number of free throws. He scores 70% of his free throws on average. Assume that scoring his free throws are independent events. Find the probability that he scores the first 3 throws. Okay, so this is just probability that he scores the first 3 throws. So the probability that he scores the first one is 0.7, 70%, and means you multiply. He scores the second one, and multiply, scores the third one. So it's just 0.7 cubed, which is 0.343. Part 2, find the probability that he scores exactly 2 of his first 3 throws. So this is a Bernoulli trial, so you've got to do n, choose or, the probability of success to the power of or, the probability of failure to the power of n minus or. This is what we're looking for. So the number of trials, 3, the number of successes, 2, so it's 3, choose 2. Probability of success is 0.7 to the power of or here, which is 2. Now if 0.7 is the probability of success, 0.3 is the probability of failure. In other words, 1 minus 0.7. So this is Q, this is P here. And that is to the power of 3 minus 2, or just 3 to the power of 1. So when you do all of that, you get 0.441. Next one, give one reason why scoring his free throws may not be the independent events. Okay, so if he scores, he may be more confident for the next throw, hence the probability of scoring will increase. Similarly, if he misses, he may feel less confident next time, and the probability may decrease. So there are other explanations or other things you could write there, but that's just my explanation. Okay, B then. The table below shows the number of games in which Rowan scored each of the given number of points. For example, Rowan scored 12 points in 3 games. Work out Rowan's mean number of points per game based on the values in the table. Give your answer correct to 2 decimal places. Okay, so this is the mean of a frequency table. There is a formula for that. Basically, you multiply 0 by 4, 6 by 5, 8 by 4, 10 by 2, 12 by 3, 16 by 1, and then add them all up. And then you divide by the sum of the frequencies here. So you add up 4 plus 5 plus 4 plus 2 plus 3 plus 1. That goes on the bottom. I did this already because it's kind of long-winded, and I got 7.05. So that is, let's see, find the mean number of points per game. So the mean number of points per game for Rowan is 7.05 if you like. Now you can use the table mode in your calculator, but that will require just writing down an answer. And if you happen to type something wrong in and you write down the wrong answer and that's all you've done, you may lose all the marks. That's the only problem there. So you got to be really, really careful typing in the numbers. Also, by the way, I should say in the exam, try not to go outside the square boxes here. These are being scanned now, so they'll only really be looking at what's inside here. They may not see what's outside here, so just be a little bit careful there as well. Okay, next one then, question 5. The diagram below, not to scale, shows a square with sides of length 12 centimeters. The circle C is inside the square and touches the 4 sides of the square. The circle K is outside the square and goes through the 4 corners of the square. So we're given just one dimension here, and that's this here, 12. But because it's a square, we know that that's 12, and that's 12. First thing, find the length of the radius of the circle C. So to find the radius, we know that from here to here is 12. So in other words, from here to here is going to be 12. Therefore, from here to here is going to be 6. So our answer here, the radius, is just 6 centimeters. Work out the area of circle C. Give your answer correct to 2 decimal places. Well, the area of a circle is just going to be pi r squared. Again, that's in your tables, so it's going to be pi times 6 squared. We want that to 2 decimal places, so it's 113.10 centimeters squared. Work out the percentage of the area of the square that is taken up by circle C, correct to the nearest percent. So the percentage that circle C takes up of the square. Now the area of the square is going to be 12 by 12, and we already have the area of the circle, so let's work through that. So the area of the square is just length times width, which is 12 times 12, which is 144 centimeters squared. So the percentage area taken up by this circle C is going to be the area of circle C, which is 113.10 divided by 144 times 100. So when you do that, you get 79%, and that's correct to the nearest percent. Part D, show that the radius of the circle K is 8.49 centimeters, corrected 2 decimal places. Okay, so we've got to work out the radius of circle K. So let's just draw a few lines here. I know that this distance here is 6 centimeters. I know that this here is going to be the radius, we'll call it R, of circle K. And I know that this distance down along here, is also 6. So really what I've got there is a right angle triangle. So I can do Pythagoras' theorem to work out R. So let's do that. So I know that 6 squared plus 6 squared is equal to R squared. 6 sixes 36 plus 36 is equal to R squared. So R squared is equal to 72. R is equal to the square root then of 72. Just square root both sides. We want it to 2 decimal places. So that's going to be 8.49 centimeters. So that's the radius of circle K. Now, last one I think here, work out the circumference of circle K. So the circumference, again, this is a formula in your tables, is 2 times pi times R. So that's going to be 2 times pi times the answer in the previous section here, which is 8.49. And when you do that, you get 53.34, and this is a circumference, so it's centimeters. Okay, so that was that question. Let's move on to question 6. Now the diagram below shows the parallelogram ABCD, which is not the scale. AB is 8, BC is 6, and the angle here is 130. Construct the parallelogram ABC in the space below. The point A is given, so we're already given this point here, as is part of the line AB. So this is the line AB here. Okay, so we've got to construct this parallelogram. So the first thing I'm going to do is construct this line here. Now I don't have a ruler, I don't have a protractor, so I'm going to be doing this freehand. You guys need to be using protractors, compasses, rulers, and so on. So let's see, construct the parallelogram. So the first thing I'm going to do is construct 8 centimeters out to here. So what you would do is you would get your compass, measure 8 centimeters on your ruler, and just draw an arc here. So that distance out there is 8 centimeters, and this point here will be B. Now the next thing you do then is we're just going to draw this angle here 130 degrees. So you get your protractor, put it here, and draw a dot here where 130 degrees is, and then just draw a line up through that, and then you know that that's 130 degrees there. Now you need 6 centimeters to go up as far as C, so again get your compass, get your ruler, measure out 6 centimeters on your ruler, draw an arc here so that you know that that's 6 centimeters, and this point here will be C. Now the next thing you're going to do is draw an angle over here at A. You know that this is 130 degrees here, so this angle here must be 50. So up along here, if we look at this diagram, if that's 130 degrees, this must be 50 degrees here, because this is a straight line here. If this is 50, the angle over here will be 50 as well. So get your protractor again, draw a dot up here such that this line is going to be 50 degrees. Draw a line up through that. Oops, just missed, but you guys will do it more accurately. And you know that this is going to be 50 degrees here. or this angle out here, if we were to continue this on, will be 130 degrees. The same as over here. Okay, so the next thing you're going to do then is, that's 130 degrees there. The next thing you're going to do is mark off 6 centimeters again. So again, get your compass, measure out 6 centimeters on your ruler, and draw an arc here so that that's 6 centimeters here. So this is going to be your point D. Next thing you do is all you got to do is get a ruler and join these up here. Now that doesn't look like a parallelogram because I'm doing it freehand, but you get the idea. That's really it. You have all your vertices identified, A, B, C, D. You have this angle identified, and you have these two sides identified. So that's all we had to do. Construct a parallelogram, A, B, C, D in the space below. The point A is given, and so on. That's it. So I would say make sure you do these arcs. As I always say, no arcs, no marks. So make sure you do the arcs and leave them there. Don't rub them out. And construct your parallelogram. That's it. Okay, so next one then. The diagram below shows another parallelogram not to scale. The size of the 3 of the angles are given, where x and y are real. Use the information in the diagram to work out the value of x and the value of y. Okay, so what do we know about parallelograms? We know that opposite angles are equal. So this here is going to be equal to 100. So 2x minus 30 is equal to 100. That's the first thing we're going to do. 2x minus 30 is equal to 100. So all we got to do here then is bring the 30 over. So you get 2x is equal to 130. Then divide by 2, so you get x is equal to 65 degrees. So there's our first answer anyway, we've got x. Now how are we going to work out y here? Well, what we know about parallelograms is that opposite angles are equal. So this angle here will be equal to this angle down here. Now the other thing we know is that all 4 angles add up to 360 degrees. So these 2 angles here must be 100 each. So they add up to 200. These 2 add up to 200, which means these 2 here must add up to 360 degrees minus 200 degrees. So they should add up to 160 degrees. So we take the 160 degrees, we divide that by 2, and that gives us 80 degrees. So each of those angles, each of these 2 angles here, that angle and that angle there, they're both equal to 80 degrees each. So x plus 3y is equal to 80 is the next thing we can write down. So x plus 3y is equal to 80 degrees. Now we already know that x is 65 degrees. So we can put 65 degrees here plus 3y is equal to 80 degrees. That gives 3y is equal to 80 minus 65. So that's 15 degrees, and that'll finally give me y is equal to divide by 3, y is equal to 5. And that's it. Now, next one then. State whether the following statement is true or false. Justify your answer. Every square is a parallelogram. Well, that's going to be true. And the reason for that is that in a square, opposite sides are equal, and opposite angles are equal, and opposite sides are parallel. So, I mean, you can get that here. If you look at this website here and go to Leaving Cert, go down to Geometry, which is here, you'll see down along here, I've got the following gives a list of all theorems, axioms, corollaries required for the junior and Leaving Cert exams. So if you open that up, just click on it, you get this document here. Now this gives a list of all the axioms, theorems for Leaving Cert and Junior Cert. If you go down to theorem number 9 here, it says in a parallelogram opposite sides are equal and opposite angles are equal. Okay, so let's look at the next question. That's question 7. So Olga is a cyclist. She is measuring how long and how steep different roads are. The diagram shows the road AB. AC is horizontal and BC is vertical. The diagram is not to scale. The gradient of the road AB is BC over AC. So it's this side here over this side here, or the tan of that angle there, if you like, written as a percentage. It is a measure of how steep the road is. In parts A1 to 4, there are 4 different values for A, B, and AC and 4 different gradients. Find the gradient of the road AB if BC is 24 and AC is 135. Give your answer correct to the nearest percent. So let's have a look at that. We have BC, which is this side here, is 24. So the gradient is going to be equal to 24 over AC, which is 135. You got to multiply that by 100. So when you do that to the nearest percent, it's going to be 18%. Find AC. So now we've got to find AC, this side here, when the gradient of the road AB is 12%. So the gradient is 12%. So that means the BC, which is this side here, that's going to be 16. That's what you're telling us, 16. We don't know this side here, AC. That's what we've got to work out. So in other words, 16 over the side AC multiplied by 100. That's how you work out the gradient. And then we know that that is 12%. So what we're going to do first is divide by 100. So we'll get 16 over AC is equal to 12 divided by 100 is 0.12. Now just multiply across by AC, and that'll give you 16 is equal to 0.12 times the distance AC. So we just come up here now. That'll finally give us the distance AC. Divide both sides by 0.12, and that gives you the distance AC. The distance AC is equal to 133 meters, and that's correct to the nearest meter. Next question. Use the theorem of Pythagoras to find AC when BC is 27 and AB is 105. Let me just write that down. ABC. Let me just draw the diagram here. So we have A, B, C. This is A here, this is B here, this is C here, and this is a right angle. So we're told that BC is 27, so this is 27 here, 27 meters. AB is 105, so this is 105 meters here, and we've got to find AC. We've got to find that distance there. So it's telling us what to do. Use Pythagoras' theorem. So we know then, using Pythagoras' theorem, that AC, if we square it, plus 27 squared is going to be equal to 105 squared. So let's work all that out. So AC squared is going to be equal to 105 squared. I'm going to just subtract the 27 squared from both sides. And then AC, I'm just going to square root both sides, is going to be the square root of 105 squared minus 27 squared. When you work that out, you get an AC of, to the nearest whole number, 101 meters. Next one then, find the size of the angle BAC when the gradient of the road is 9%. Give your answer to the nearest degree. So we have ABC again, so we have ABC. This is ABC, and this is a right angle here. We've got to find the size of the angle BAC. We've got to find this angle here when the gradient is 9%. So another way of writing 9% is just 9 over 100. So you can imagine that the gradient then being 9 over 100 means that BC could be 9 and AC could be 100, and then we would just multiply by 100 to find the percentage here. So 9 over 100 is our tan of the angle at A. So what we're going to do is say 9 over 100 is equal to the tan of the angle BAC. So all we've got to do then is get tan inverse of 9 over 100 to give us the size of the angle BAC. So when you do that, you get 5 degrees, and that is to the nearest degree. Let's have a look at the next question then. B. Olga wants to measure the distance between 2 points R and O. She marks the point P on the ground so that the distance from R to P is 20 meters. She measures the angle at P and R, so 88 and 87 degrees. All of these are shown in the diagram below, not the scale. Work out the distance OR, so this distance along here. Give your answer correct to the nearest meter. So this is going to be the sine rule here. So what I'm going to do first of all is work out this angle here. So if we take 180 degrees, that's what all three angles in a triangle add up to. I'm going to subtract 88 degrees. I'm going to subtract 87 degrees, and that'll give me 5 degrees. So that's the angle up here at O. So now I'm going to use the sine rule. So I'm going to say sine of 87 degrees divided by the opposite side, which is what we want to know, that's OR, is going to be equal to the sine of 5 degrees over 20, its opposite side. So we have an equation here, we have everything in there except what we need. Again, we have a fraction equal to a fraction, so you can cross multiply here. So I can say 20 sine 87 is going to be equal to the distance from O to R multiplied by sine 5 degrees. So to find the distance from O to R, just divide both sides by sine 5. So I have 20 sine 87. Divide that by sine 5 degrees. And that'll finally give me a distance from O to R. All that is on the left hand side is just calculator work. So you can do that. We need this to the nearest meter. So do that on your calculators and you'll get 229 meters. Okay, next one then. Olga has already worked out the distance between 3 points. So we have 700, 550 and 800. Not to scale. Work out the size of the angle X, this angle down here in the triangle XYZ. Give your answer in degrees. Correct to 1 decimal place. Now when you've got 3 sides of a triangle and you're asked to find one of the angles, you can use the cosine rule. So that's what we're going to do. So start with the side opposite the angle that you're looking for. So we're going to start with 550. We're going to square that. Look at the other 2 sides then. 700, square it. 800, square it and add them. Then subtract both of those sides multiplied. So 700 times 800. And then it's the cosine of the angle opposite this side here. So the angle opposite that side there is the angle that we're looking for. So it's going to be the cos of angle, we'll call it angle X here, okay? Now, you've just got to do all this and isolate X. So let's do them all one by one. So 550 squared is 302, 500. 700 squared is 490,000. 800 squared is 640,000. When you multiply these 3 together here, you get 1120. 3 zeros again, and cos of X. Next line then, what I'm going to do is I'm just going to add these 2 here. So I'm going to add those 2 first, and then I'm going to bring it over to the other side. So I've got 302, 500. Add these 2 here, you get 1130,000, then minus 1120,000 cos X. Okay, so next thing I'm going to do is I'm going to take the 1130,000 and bring it over to the other side. So I'm going to subtract that from both sides. When I do that, on the left hand side I get 827,500. On the right hand side I get minus 1120,000 cosine X. Next thing I'm going to do is I'm going to divide. This here is multiplied by the cos X, so I'm going to divide by that. So if you do that, you get 331 over 448. That's equal to cosine X. So minus divided by minus is plus, so this just becomes plus. Now to find x then, if cos of x is equal to that fraction, what you've got to do is cos inverse of that fraction. 331 over 448, and that gives you the angle x, the size of the angle x if you like. I'll write that out. So it gives you the size of the angle at x. So let's see our answer then. The size of the angle at x there is going to be cos inverse 331 over 448. You can do that on your calculator. We need to do it to one decimal place, so it's going to be 42.4 degrees. That's our answer there. Okay, so let's have a look at the next question. Question 8. A family decides to buy a small paddling pool for their back garden. The pool is in the shape of a cylinder. It has internal diameter 2.4 meters and internal depth of 0.9 meters. Now the instruction manual recommends that the pool should be filled to a maximum depth of 0.75 meters. Work out the volume of water in the pool when it is filled to this maximum depth. Give your answer in meters cubed corrected 2 decimal places. So really this is just the volume of a cylinder. The volume of a cylinder is pi r squared h. Again, that's in your tables. So pi, we'll just take as pi from the calculator, or the radius in this case is 1.2. It's 2.4 diameter, so 1.2 is the radius. So we're going to take 1.2, square it, and the height, the maximum height, is going to be 0.75. Okay, we need this to 2 decimal places, so it's going to be 3.39, and that's meters cubed. Next question. The family buys 3 pool seats. Each pool seat is a cube with sides of length 0.5 meters. Show that the total volume of the 3 pool seats is 0.375. So a cube, if it has a width of 0.5 meters, it also has a length of 0.5 meters and a height of 0.5 meters. So the volume of, let's say, 3 cubes is going to be 3 times length times width times height. So it's going to be 3 times 0.5 times 0.5 times 0.5. So when you do all of that, you do get 0.375, and again that's meters cubed. Next one, the pool is filled with water to a height of 0.6 meters. The 3 pool seats are put into the pool so that each seat is fully covered with water. Find the amount by which the water level in the pool rises. Give your answer in meters correct 2 decimal places. Okay, so what's happening here is we have a cylinder, let's say like this, and you have water in there, let's say to this level. Now what happens then is the 3 seats are put in, so the 3 cubes here are put in, and the water rises. Let's say it rises to this depth here. So what's happening then is the water has risen this amount here, let's call it h. That's what they're asking for in this question. They're looking for how far the water has risen. Now, the shape of the water that I've just shaded in here is a cylinder. So really we're looking for the volume of a cylinder again. And we know that that's pi r squared h. Now we know the volume of our 3 seats. We know the volume of the 3 seats is 0.375 cubic meters. So that's going to be the volume of this shaded in, shaded in part here, this cylinder here. So that's going to be equal to, pi times the radius of that cylinder. It's going to be the same as the radius of the entire cylinder. So that's again 1.2. And we've got to work out what h is. So really, all of these things on the right-hand side are multiplied, so we can bring them over to the other side and divide them. So it's 0.375 divided by pi times 1.2 squared. That'll give us our h. Now, when you do that, you get a h of 0.08 meters, and that's 2 decimal places. That's it, really, for that part of the question. Let's have a look at C. The family also buys a cover for the pool to help keep the water clean. It's in the shape of a right circular cone with radius 1.3 meters and vertical height of 0.8. Show that the slant height of the cone marked L in the above diagram is 1.53 meters, corrected 2 decimal places. So what we've really got here again is just a right angle triangle. So we can just do Pythagoras' theorem to find L. So it's going to be 0.8 squared plus 1.3 squared is equal to L squared. So L then is just going to be the square root of all of that, which you can just put into your calculator. And when you do that, you finally get an L, or a slant height, of 1.53 meters. Okay, work out the curved surface area of the conical cover. Give your answer to 2 decimal places. Now there is a formula for this in your table, so the curved surface area is going to be pi times r times L. So that's pi times the radius of our cover here is 1.3 meters, so that's our radius, so 1.3. Multiply that by the L that we just got, or we were given in the question anyway, so it's 1.53. So when you work out the curved surface area, you get 6.25 meters squared because it's area, and that is to 2 decimal places. Okay, next one. The diagram below shows the net of the conical cover not to scale. It is a sector of a circle of radius x. Write down the value of x and work out the size of the angle A correct to the nearest degree. Now, if you imagine that this is the net of the cone, we would need to join that up to that to make the cone, make a three-dimensional cone. Currently, this is 2 dimensions. So when you join that up to that, really x is going to turn out to be this distance here. That's the 2 points joined up, if you like. So it's really L. And we worked out L as 1.53. So our L, or our x in this case, is 1.53 meters. We've got to work out the angle A now, okay? So what we're going to do here is look at the area of this shape here. Now remember, we worked that out up here. It's the curved surface area, 6.25. So that's 6.25 square meters. The entire circle we can work out as well. So let's work out the area of the entire circle. So the area of a circle is pi r squared. So that's pi times 1.53 squared. Because remember, the area of this entire circle, if you imagine you join that up to that there and make an entire circle, the radius would be just 1.53. So when you work that out, what you're going to get is 7.3541544243, and that's meters squared. That's the area of the entire circle. So what we need to do is find the proportion of the circle that we're talking about. So we know this area here of the sector, that is, again, that's 6.25. So if we put 6.25 over 7.3541544243, we don't need that many decimal places. This is the fraction of the circle that we're talking about. This is this part of this circle here. So that's the fraction of the circle that we're talking about. We want the angle, so let's multiply that by the entire circle, which is 360 degrees. When you do that, you get to the nearest degree is 306 degrees. I think that's what they asked for here. Write down work out the angle A correct to the nearest degree. Yeah, so it's 306 degrees. 306 degrees. Okay, so let's have a look at question 9. A group of students decide to investigate the average amount of time that students spend in Ireland reading each day. One Monday morning, they asked the first 200 students who came into their school how long on average they spend reading each day. The results are shown in the table. So this is a grouped frequency table, and we can see here that we've got 0 to 30 minutes, 16 students. 35 students spent between 30 and 60, and so on. Okay, so first thing, work out the maximum number of students in the sample who on average would have read more than 100 minutes per day. Well, more than 100 is going to be in here. So these 59 could have read more than 100. So you got 59 plus 18 plus 10 is going to be the answer there. So it's 59 plus 18 plus 10. If you do that, you get 87. So the answer to the first part is just 87. Next part. Estimate the median time spent reading by these 200 students as accurately as possible. Justify your answer. Okay, so the median number is going to be somewhere around here. There are 200 students, so if you take 200 students, divide it by 2, you're going to get 100. So it goes in evenly. So the median, in other words, will be the 100th plus the 101st number divided by 2, whatever that happens to be. So if we look at our table, the 100th student is going to be here somewhere, because if you add 16 and 35, so if we take 16 plus 35, we get 51. If you take 51, so in other words, we're looking at 51 students up as far as here. If we add another 62, so if you add 62 there, you get 113. So now we're past the 100th student at this stage. So the 100th student must be in here somewhere. Now it's impossible to say here what the median is going to be exactly, because these 62 students could have spent 60 minutes per day reading. They could have spent 89 minutes per day reading. You don't know what way these 62 students number of minutes reading per day is spread out between 60 and 90. So it's really impossible. So the best estimate that we can make really is somewhere between 60 and 90. So what I'm going to say here is the mid-interval value. So I'm going to add these two, divide by 2, which would be 75. So I'm going to say 75 minutes, right in the middle of these two. Because as I say, we don't know what way these 62 students are spread out between 60 and 90. So I'm going to say 75. So the mid-interval value of 60 and 90 is 75 minutes. So my answer then is going to be 75 minutes. So let's move on to the next one. Explain why the method of choosing the students in this survey could limit the validity of the conclusions. Okay, so the group of students decided to investigate the average amount of time the students in Ireland spend reading each day. So one morning they asked the first 200 students who came into their school how long on average they spent. So they're only looking at the number of students in their school. And the purpose of this whole investigation is to decide or to find out the amount of time students in Ireland spend each day. So the sample is very small and it's confined to one school. So I'm going to say here the sample is very small and also confined to only one school. So the question was, explain why the method of choosing the students for the survey could limit the validity. So that's what I'm saying, that it's too small a sample, only 200, and it's also confined to only one school. Okay, draw a graph or chart to represent the data in the table. Show clearly any relevant calculations. Label your graph or chart clearly. So what I'm going to do here is draw a histogram. Okay, so this is the graph I've drawn. Now I've drawn it freehand, so you guys obviously would need to use a ruler. You need to make sure you put in a title and titles on the X and Y axis as well. So on the Y axis here I have the number of students, and on the x-axis I have the time spent reading, and make sure you put the units in as well. So I've gone up 10, 20, 30, 40, 50, 60, and I've just read off each particular number of student value here. So the first one was 16, for example, so I've gone up here to 16, and down here that's between 0 and 30 minutes. 60 to 90 was 62, so 60 to 90 is here, and I've gone up to just over 60 here. And that's it really, that's your histogram or your graph. A random sample of 500 students in Cork took a statistics test. 61 of these students were given a rating of excellent. Work out the percentage of students in this sample who were given a rating of excellent. So what we've got to do here is just take the 61, put that over 500. So it's 61 over 500, multiply that by 100, and that gives you a percentage of 12.2%. So straightforward enough. Show that the margin of error for this sample is 4.5% correct to one decimal place. Okay, so your formula for margin of error is just going to be 1 over the square root of n. So in this case, the error is going to be, the margin of error is going to be 1 over the square root of 500. And when you do that, you get 4.5%. That's to one decimal place. Okay, next one then. In general, 10% of students get a rating of excellent on this statistics test. Use your answer to part B 1 and 2 to test the claim that the percentage of students in Cork who would get a rating of excellent is different to the population percentage at a 5% level of significance. Show the relevant calculations, state your conclusion, and give a reason for your conclusion. So this is basically a hypothesis test. So what you've got to do here is state the null hypothesis and state the alternative hypothesis. So the null hypothesis is that 10% of students in Cork would get an excellent rating. And the alternative hypothesis then is that the percentage of students in Cork who would get an excellent rating is not 10%. So our calculations is going to involve doing a confidence interval for the proportion. So that's going to be, P is going to be greater than or equal to, less than or equal to our P hat minus the margin of error, our P hat plus the margin of error. So in our case then it's going to be, the P hat is going to be 61 over 500. So because remember up here it says a random sample of 500 students in Cork took a statistics test. 61 were given an excellent rating. So our P hat is going to be 61 over 500, which is 0.122. We've got to subtract the margin of error. In our case, the margin of error up here is 4.5, or when we convert it to a decimal, 0.045. So you've got to take 0.122 on this side and add the margin of error. So we're going to add 0.045. So if we do all of that, we get, on the left hand side we get 0.067, which is 6.7%. On the right hand side then we get 0.167, so that's 16.7%. So this is our confidence interval for the proportion of the population who would get an excellent rating. So let's have a look then at our conclusion. So our conclusion is going to be that we fail to reject the null hypothesis. So we fail to reject the null hypothesis, and then we would say something like the percentage of students in Cork who would get an excellent grade is not different to the population percentage. In Ireland, if you like. Okay, so the reason for the conclusion is that 10% is outside our confidence interval. Okay, so that's it for the hypothesis test. Okay, so let's have a look at the last question, question 10. The toy company makes spinners in the shape of a regular pentagon as shown in the diagram on the right, not the scale. Each of the 5 sides of the pentagon A, B, C, D, E is the same length. The pentagon is divided into 5 congruent isosceles triangles. Each triangle contains the point O. The angle BOC is 72 and OA is 6. Okay, work out the angle CBA. So that's from here to here to here. So we got to work out this angle here. Size the angle CBA. Okay, so there's a few ways of doing this, but if you imagine you have, well, we do have a pentagon. So it looks, let's say, something like this. What you can do is divide this up into triangles. So you can come across here and then come down along here. So you can actually divide it into 1, 2, 3 triangles. Each triangle has 3 angles, and those angles add up to 180. So we have 180 degrees in each triangle. We have 3 triangles, so that'll give us a total of 540 degrees. So that just means that these angles here all add up to 540 degrees. So we want one of those angles, so we're going to take 540 degrees, we're going to divide that by, there are 5 angles in a pentagon, so we're going to divide that by 5, and we get 108 degrees. So that's equal to our angle CBA. So that angle there is 108 degrees, that's 108, that's 108, that and that, they're all 108 degrees. So next part, work out the area of the triangle AOB. So that's AOB. So the area of this triangle here, which is going to be the same as this one here, is going to be the same as all of these triangles. And hence work out the area of the pentagon, ABCDE. Give your answer correct to 1 decimal place. So we have a small triangle first, so that's going to look something like this. This is 6 centimeters, this is 6 centimeters, and this is 72 degrees. So we're going to say that the area of this triangle is half AB sine C. So that's going to be half times 6 times 6 sine of the angle in between the two 6's, which is 72 degrees. When you work that out, you get 17.1 square centimeters. So the area of AOB is 17.1 centimeters squared. The area of the pentagon then is going to be 17.1 multiplied by 5. When you do that, you get 102.6 centimeters squared. So this is 102.6. Okay, next one. The triangles in the spinner numbered 1 to 5 is shown. The spinner spun twice, and each number landed on is recorded. Write down the sample space to show all of the 25 possible outcomes when the spinner is spun. It may be useful to draw a two-way table or to list the outcomes in a systematic way. So I'm going to do a two-way table. So my two-way table is going to involve the outcomes 1, 2, 3, 4, 5. So they're all the outcomes. And I'm going to put them down here as well. So we got 1, 2, 3, 4, 5. So I'm going to say that this is the first spin, and this is the second spin here. So here we would get 1, 1, then we get 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and so on. And that's it. I think that's all we had to do. Write down the sample space to show all 25 possible outcomes. Okay, so we've done that. Now, the spinner is spun twice and the two numbers are added. What is the maximum and the minimum possible totals when the two numbers from the spinner are added? So the minimum is just going to be this one here, 1 plus 1, which is 2. And the maximum then is going to be this one down here, 5 plus 5, which is 10. So the maximum is 10 and the minimum 2. Each time the spinner is spun, each number 1 to 5 is equally likely. Work out the probability of getting a total of 4 or 5 when the two numbers are added. Okay, so now we need to add all of these. So if you add them, here you'll get 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, and so on. We want either 4 or 5. So where am I going to get 4 or 5? Let's have a look at that. So we're going to have a 4 here, 4 here, and a 4 here. We're going to have a 5 here, 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 and here. So in total we got 1, 2, 3, 4, 5, 6, 7. So it's 7 out of 25. So we've got to work out the probability of getting either a 4 or a 5. So the probability of getting a 4 or a 5 is just 7 out of 25. That's it. Okay, next part then. In a different spinner, there are 4 different outcomes: north, south, east, west, or NSCW. In a game, Jenna pays €1 to spin the spinner. The table below shows the probability of each outcome as well as the money Jenna will get depending on the outcome. So she will get €1 if she spins and gets an N. She'll get 50 cents if she gets an S. She'll get nothing if she gets E, and €5 if she gets W. So the question is the game fair? And justify your answer. Work out the expected value of this game as part of your solution. Okay, so the working out then is just going to be the expected value. So we want the expected value. So it's going to be 0.3, which is the probability, times what you would win, plus 0.2, which is the probability of winning 50 cents, plus 0.4 times the probability of getting an E, which is 0, plus 0.1 times the probability of getting a W, which is €5. Now you just do all that on your calculator and you get €0.9. So that's the working out. It says, is the game fair? So the answer is no. And the reason is, since, is it Jenna? Yeah. Since Jenna pays €1 to play the game, and she will win €0.9 on average per game. The game is unfair. Okay, and that's it for this question and this paper.